Hi friends, this video we are going to see the function is analytic and f prime of z is not equal to 0, then their level curves are orthogonal. Let w equal to f of z. You can write f of z is u of x comma y plus I times v of x comma y be analytic and f prime of z is not equal to 0, then the level curves of u and v are orthogonal. So these conditions plays a very important role. Okay, so function is analytic. So now we see one example. F of z equal to z. So what is u of x comma y in our problem? X. V of x comma y equal to y. Then what is how to say two things are hard. Now you are going to the gradient of u equal to I, gradient of v equal to j. This implies gradient of u dot gradient of v is 0. So that's only u and v are orthogonal. Second example, here clearly look here, f prime of z is 1, it is not equal to 0. Now we see the second example. This example we will get the degenerate points. So whenever f prime of z equal to 0, those points we call as a degenerate point. F prime of z equal to 0, then z is, suppose z naught you take, z naught is degenerate point. Now we see one more example, f of z equal to z square is the first one. Now you take second example, f of z equal to z square, that meaning is x square minus y square plus 2i times xy. So this implies u of x comma y equal to x square minus y square, v of x comma y equal to 2 times xy. So now I want to check that any degenerate points will be there. So we take f prime of z is 2z is not equal to 0 for all z not equal to 0. So now we no need to consider about z is equal to 0 points. Now what will happen? U of x comma y, gradient of u is 2 times x I cap plus minus 2y times j cat. Gradient of v is, so 2y times I hat plus 2x times j hat. Now gradient of u dot gradient of v equal to 4xy minus 4xy equal to 0. Now what is the problem at z equal to 0? So clearly this u and v are orthogonal at each for all z is not equal to 0. What will happen? Z is equal to 0. Now you see the level curves at z is equal to 0. So x square minus y square equal to 0 implies y equal to plus or minus x. Similarly, 2xy equal to 0, this implies x equal to 0 or y equal to 0. So you clearly draw the graph. What will happen? So you clearly draw the graph. Y equal to plus x means what will come? Y equal to plus x means you will get it the line, this line will come. Y equal to plus x. Y equal to plus x. This is y equal to minus x. So clearly look, the angle is, here is 45 degree will come. Here means suppose this curve, and here means, sorry, here to here. Here means you will get it as 135 degree will come, and here to here also 135. So this will happen. So whenever, so that is why we are not consider those points. Clear? So these points are called degenerate points. So the function is orthogonal everywhere except z is equal to not equal to 0. So we see the graph wise. So this is the first function, z is equal to x plus iy, u equal to x. Okay, so if you put it as u equal to 1 or 2 means you will get the x equal to 1. So x equal to 1 means this line will come, x equal to 2 means this line will come, x equal to 0 means y axis will come. Similarly, v axis means v equal to 1, that is y equal to 1. Similarly, y equal to 1, y equal to 2, y equal to 3. So clearly these all families of curves are cuts orthogonally. Correct? So this is the first point, first example. Second example, now you look, this is the case will arise. So this is approach to the u equal to 1 or 0, you will get the line is this one. This is the line you will get it, x equal to y and y equal to x. So these two curves everywhere cuts orthogonally except origin. I hope you understand. So whenever the function is analytic and f prime of z is not equal to 0, then their level curves cuts orthogonally. Thank you for watching this video.